In today's video, we're going to look at section 10.3, which is the amortization of loans. This is just kind of a fancy way of phrasing paying off a loan, but there are a couple other properties to this that we need to be aware of. First thing is that we are paying this off at regular intervals in equal payments. So let's say you pay off $100 every month. Okay, so you're paying it off at regular intervals with equal payments. But the other property to this, which is exactly as we have looked at before, when either we are paying for something or someone is paying us, the interest is accrued at the same interval as the payments are made. So your interest periods coincide with your payment intervals. So let's say that your interest is compounded monthly, therefore you're making monthly payments. Okay, so they're always going to coincide. Again, as always, we are paying towards this at the end of each interest period. So payments are made at the end of an interest period. It's basically going to be a fancy decreasing annuity. Okay, we're going to be using the exact same formulas because if you think about it, you are given a lump sum at the beginning from a bank. Okay, so you have this lump sum that you are then paying down to zero. Okay, it's just an opposite transaction to what we had when we were dealing with before decreasing annuities, where we gave the bank a lump sum and we were taking money out of the bank at regular intervals. This time the bank is paying us a lump sum and we are paying back the bank at regular intervals, but still that account will go to zero. So it's just a fancy decreasing annuity where payments are made the other way around. So the payments are going to be the rent. So whenever we try and figure something out using the formulas that we did with decreasing annuities, when we had those formulas, we had a formula for R, which was the rent payment, how much we would get paid at those payment intervals. That's going to be the payments that we will make towards the loan. So R will be the payments, and then that P value, which was the present value that you currently had in the account, that will be the principal amount left on the loan. So it tells you how much you actually have left that you owe to the bank, but you will have interest on top of that. So principal is just the principal amount, the amount left that you owe the bank plus interest. So that will be that P value that we were looking at when we had the formulas for decreasing annuities. So R will be the payments and P will be the principal value left on the loan when you had N payments left to make. Okay. I'm going to do a couple examples to show this. You can also do this using the TVM solver on your calculator, exactly the same as we did in the last video. The only difference is, remember that we said if you are paying the bank, it goes in as a negative. If the bank is paying you, then it goes in as a positive. So now that present value, the principal amount, is going to go in as a positive number, and then the payments that you make to the bank are going to go in as a negative number, and that future value will be zero. So just kind of keep that in mind. It's just going to be opposites with negatives and positives for that TVM solver if you decide to do it that way. I'm going to do it both ways and kind of tell you what you're going to put things in as for the calculator, as well as how to do this using formulas. And I'm going to do two main examples here, one of which is actually out of the textbook because I think it covers a lot of bases. There's a lot of parts to it, and the other one is just a standard example that you will see in this section. So the first question is, suppose that we have a loan and it has an interest rate of 6% compounded monthly and a term of 5 years. Okay, compounded monthly, term of 5 years, that means that we are paying back every month at the end of each month for 5 years. That already tells me that I'm making 60 payments. The principal amount, so the amount that I borrowed from the bank, was $10,000, and I'm going to calculate the monthly payment. Okay, again, remember, this is a type of decreasing annuity. It coincides with what we did with that. So your rent payment, the payment that we are making towards the loan in this case, the formula for that was I over 1 minus 1 plus I to the negative n multiplied by P, where P is now our principal amount. Okay, it's the amount that we have left to pay off the loan. I is the interest rate per period. So in this case, we have 6% compounded monthly. So I would be 0.06 divided by 12 because it's the interest rate per period. It was 6% compounded monthly, which tells me that I is 0.005. Okay. N is the number of payments. Well, we're paying back every month for 5 years, so it's 12 months and 5 years, so that means that N is 60. And then P is the principal amount. P is just the $10,000 that I borrowed from the bank originally. If you plug all of that into that formula, you should find that your loan every month is going to cost you $193.33 if you round it. Again, we're dealing with money here, so round it to 2 decimal places. It's $193.33. If you go to your TVM solver, so you're going to go into apps on your calculator, finance and TVM solver. I'm going to tell you what the numbers are to plug in. So this time N, so it's a capital N, N is the number of payments, which again is going to be 60. Okay, we've got 60 payments here. I is the interest rate that is stated. It deals with the fact that it's compounded monthly, that comes later on. I is just the stated interest rate here, this 6%. So we're going to type in I is 6. Our present value, okay, that's just our principal amount on the loan, the amount that we borrowed, and it's the money that we get from the bank. Okay, so this time it's a positive, so it's $10,000. The payment we don't yet know. The future value is 0. Okay, we're trying to pay off the loan, the future value would be 0. And then both your payment period and your compounding period, okay, is monthly. So per year there are 12. And remember again, the payment is made at the end, so make sure the end is highlighted. And then all you do is go to the alpha button and enter. That will solve for the payment for you. So then just highlight the payment value and click alpha and enter. And that should give you negative 193.33. That's how much you owe the bank every month, which coincides with exactly what we got from our payment here, okay, from this formula. The second part of this problem, again, this is a popular question that they will give you. Given what the monthly payment is, so now that we've found this monthly payment, calculate the unpaid balance after 1 year. Okay, so after 1 year, we still have 4 years left to pay off this loan. How much do I have left when I've got 4 years left to pay off the loan? Okay, we've paid off some of it, this $10,000 already as we've been making monthly payments, but you tend to find with loans, you end up paying a lot of interest at the start. Okay, if you think about it, I start off with $10,000. Okay, in the first month, I am paying 0.5%. That's what this is, 0.005 for that interest rate per period. So in a month, I am paying 0.5% of interest on the remaining balance of the loan every month. So the first month, I am paying 0.5% of interest on the $10,000 I took out. Okay. Then I make my first monthly payment at the end of that month. That will leave me with a certain amount of money, okay, that I have left to pay off on this loan. It'll be $9,000 and some change, okay. I then, my next month, end up paying 0.5% interest on that $9,000 and something, okay. These are huge numbers compared to my final few months where I'm paying 0.5% interest on a very small amount, okay? Couple $100 left, okay? So you tend to find at the very start of this payment process, most of these payments and most of this $193.33 that I'm paying, the majority of that will actually be interest, okay? But as you get down the line and you get to your last few payments, the majority of that $193.33 is actually just the principal amount that you have left to pay off. Because the interest amount, that 0.5% of whatever you have left on the loan, let's say, I don't know, $1,000, 0.5% on $1,000 is a very small amount of interest compared to 0.5% on $10,000. So the majority of the payment, the majority of that $193 that you're paying each month at the start, the majority of that goes towards interest. But as you go through these payments over the 5 years, that $193 that you pay at the end, most of that goes to principal because you're paying such a small amount of interest on a small amount, okay? 0.5% on, let's say, $1,000, okay? So you tend to find that with loans. Same goes with mortgages, okay? The first few years of a mortgage, you tend to find that you are paying, let's say, $2,000 a month for a mortgage. The majority of that $2,000 at the start is going towards interest to the mortgage company. But as you go through this, as you get towards the end of the life of the loan, let's say you got a 30-year mortgage, as you get towards the end of that, the majority of that $2,000 that you're paying a month goes straight towards the principal that you took out at the start. That's just kind of how these loans work with interest that is paid on them. But what we want to do now is, given this monthly payment, calculate that unpaid balance after a year. When I have paid monthly payments for a year, I've already made 12 payments, okay, out of these 60 payments that I have to pay out. That means that I have 48 payments left to make of $193.33. So my end value is now going to change to 48. I now know my R value of $193.33. I know what I is still 0.005. I don't know what P is now. I want the present value of the loan, the principal amount left when I have 48 payments left of $193.33. So again, I go back to my decreasing annuities and I put in P, okay, which is the thing that I want to find out, was 1 minus 1 plus I to the negative n multiplied by R over I. This time we know R is $193.33. We know that I is 0.005. And now I want to find what my principal value left is when n, the number of payments left to make, is 48, because I'm looking at what happens after 1 year. So I have 48 payments left to make. If you go ahead and do that, that your principal value would be $8,231.97, okay? When you plug all of those into that formula. You can again use the TVM solver on the calculator. This time you do the exact same thing as before, but now n is going to be 48. The interest stays the same. I'm now looking for this. My payment value I put in as negative 193.33. My future value is still 0 and my payment and compounding rates stay the same. So now you just solve for your present value and you should get the same answer. Okay. So after a year of these $193.33 payments, I've made 12 of those, but I still have, after a year, over $8,000 left on this loan to pay off. Okay. So whenever you do these, my advice to you would be to use both the formulas, but you can use the calculator as well. The calculator is a great check to make sure that you have used the correct formula and done this the right way. So I would highly recommend that you get used to using that TVM solver as well. Okay, our next example is from the textbook, and this is a classic mortgage example, and it actually covers several bases, so I want to go through the whole example. Some of it is just like what we've just done, but it also introduces some of those ideas about interest and how much you pay on a particular month, how much interest you pay for a particular year, and how much is paid over the life of the loan. So I'd really like to go into this so that we can see exactly how it all works. The problem states that we are taking out a 30-year mortgage where we have $112,475 that we've taken out for this mortgage, and we have a 9% interest rate compounded monthly. The mortgage payments are made at the end of each month, so again we're compounding the interest monthly and the mortgage payments are made each month. We want to first calculate the amount for the monthly payment. So how much are we paying for this mortgage every month? Okay. Again, we're looking at a payment amount. If we look at our formulas, we look at the formula for R for a decreasing annuity, which told us that R is equal to I over 1 minus 1 plus I to the negative n multiplied by P. Okay, so we need to know what I, N and P are. I is the interest rate per period. Okay, so we've got 9% interest compounded monthly, so that would be 0.09 divided by 12, which would be 0.0075. Then N is the number of payments that we make. Okay. N would be 30 years, and we're doing this monthly. So we've got 12 multiplied by 30, which would give me 360. And then P is the present value, the principal on the loan for the 360 payments, which is 112,475. Okay. If you plug all of that in, you should find that your monthly payments are $905. So the amount of the monthly payment is $905. It actually rounds out to 0.00 if you round to 2 decimal places. Again, you can do this on the calculator on TVM solver. Okay. Your present value would go in as a positive, your future value would be 0, and then the payment that you get back, this value here will just come out as a negative. Then we want to calculate the unpaid balance of the loan on December 31st, 2022, just after the 312th payment. Okay. We are making 360 payments in total over 30 years. Okay. If we've made 312 payments out of the 360, that tells me that I have 48 payments of $905 left. Okay, so I've paid 26 years of this. I've got another 4 years of payment. So I need to find out how much I would pay, what the unpaid balance on the loan is, when I still have 48 payments left of $905. So I'm going to plug that now into my formula, and I'm trying to find the principal amount that is left when I have 48 payments left to make. So N is 48. I, again, with the interest rate per period, would be 0.0075. And R, I now know my monthly payment to be $905. So if you plug all of that in, you find that when you have 4 years left, that your principal amounts, the amount that you still have left to pay, plus interest on this, But the amount that you still have left to pay is $36,367.23. Okay. Let's think about this for a second, because this is going to come into play as we do the next couple problems on here. You took out a mortgage, we saw, of $112,475, okay, on a 30-year loan. After 26 years of paying this off, you've only got 4 years left, but 26 years, you still have about a third of the loan left to pay off, okay? So with only 4 years remaining, you're actually going to pay off this last third of the loan. It took you 26 years to pay off about 2/3 of it, and you still have to pay off that last third of it in the last 4 years. That is because the majority of the payments that you were making, so the majority of the $905 that you were paying each month, was going towards interest, because you were paying interest on the unpaid balance, so on whatever balance, whatever the principal amount that was left was, you are paying interest on that every single month. You are paying, let's say, 0.75% interest on whatever the unpaid balance is every single month. Now, 0.75% interest on $112,000 is a lot more than 0.75% of $36,000. So that is why you end up paying so much interest at the start, okay? The majority of your payment, the majority of that $905 each month at the start was basically straight up interest, okay? It was going to interest payments rather than the principal amount that you actually took out at the start. But as you get towards the end, the majority of that payment goes towards the principal value, because the interest on these smaller amounts is a lot smaller. So a lot more of the $905 gets a chance to go towards the principal rather than the interest. Okay. The next part of the problem starts to look at the interest and how much you actually end up paying. So how much interest will be paid during the month of January 2023? Okay. Well, at this point for that month, you are paying interest on the interest per period on the amount that was left on the loan the month before. So we found out that after our payment in December of 2022, we still have $36,367.23 left to pay off. Okay. So during the next month, I'm going to accrue interest on that amount. How much interest am I going to accrue on that? Well, I'm going to accrue 0.75%. Okay, remember this is as a decimal, so it's going to be 0.75% of this amount is how much interest is accrued that month. Okay, because I is the interest rate per period, and we are just looking at how much interest was paid in that 1 month. So we find that if we do 0.0075 multiplied by the amount that was left on the loan from the month before, that's the same thing as saying 0.75% of $36,367.23, you find out is $272.75. That is the interest that is accrued on that amount that you have left on the loan. So out of your $905 that you pay in January, $272.75 of it goes towards interest. The rest of it will go towards your principal balance. The rest of it will go towards this $36,000 that you have left to pay off the loan. But $272.75 of that is just interest. Okay. If we would have done this calculation for a much earlier payment, much earlier in the life of the loan, so in the first year or two, you would get a much higher number here, which would mean that the majority of that $905 was going straight to interest. The next part of the problem says how much of the principal will be paid during 2022. Okay. Well, to see how much principal will be paid during 2022, we just have to see how much unpaid balance there was at the end of 2021, and then subtract how much unpaid balance, how much principal we have left at the end of 2022. We already know the answer to the second part of that. We already know at the end of 2022, we have this $36,367.23 left to pay off. How much do we have left at the end of 2021? Okay. At the end of 2021, we still have 5 years left of paying off the loan. We said that at the end of 2022, we had 4 years left. At the end of 2021, we have 5 years left. You're going to do this exact same calculation, but now put in N is 60. If you do that, P comes out to $43,596.90 if you put in N is 60. So that is what the principal balance is, how much you've got left of the loan to pay off with 5 years remaining. So at the end of 2021, that is how much you've got left to pay off. At the end of 2022, we had $36,367.23 to pay off. So how much principal balance, how much of the loan did we pay off during that year? Okay. All we do is we subtract one from the other. So the amount of principal repaid in 2022 will be how much we had left on the loan at the end of 2021 minus how much of the loan we had left at the end of 2022, which should give us $7,229.67. Okay, that's how much we had left, and that's how much that we repaid during that year. Okay, we paid more than that because if you think about it, we were paying $905 for 12 months of the year. That's $10,860 that we actually paid out. But only $7,229.67 of that went towards the principal balance that we originally took out. The rest of it went to interest. Okay, that's actually the next question. The next question asks, how much interest was paid in 2022? Okay. The interest that is paid in 2022 would be how much we actually paid minus the principal amount that was paid in 2022. So we said that during 2022, we paid $905 a month for 12 months of the year. So that's how much we actually paid minus the principal balance that was actually repaid, which was $7,229.67. Which turns out to be $3,630.33. So that is how much interest we paid in 2022, and $7,229.67. That's how much principal. So that's how much of the $112,000 that we originally took out was actually paid towards. The rest of it, this $3,630.33, is just the amount of interest that was paid during that year. Okay, so the two added together would be that $10,860 that we actually paid. So it's the $905 12 times. The last part of this problem looks at how much interest you paid overall over the life of the loan. So over the 30 years, how much interest was paid. Okay. Well, the interest that you paid over 30 years would be how much you actually ended up paying for the loan. So the $905 multiplied by 12 multiplied by 30, so it would be the $905 360 times, and then we're going to subtract what the principal amount of the loan was. So how much did you actually take out at the start? So it would be 905 multiplied by 360, that's how much you actually paid, minus how much you actually took out for the loan at the very start. If you do that calculation, you should find that you get $213,325. Okay, so it turns out this amount here would be $325,800. So for a $112,475 mortgage, you ended up paying $325,800. So you ended up paying over $200,000 in interest. Okay, so this is kind of how mortgages work. Even though you may end up with a smaller mortgage and a decent monthly payment, you actually end up paying a lot in interest. So that's why I like these problems. They are very much real world and they show you how these mortgages work.